My name is Mark Storr, Tech Service Rep for BASF here in central Iowa. And stop today I want to talk a little bit about is fungicides and plant health and development of fungicides. Just kind of lead people through a little bit of the history of fungicide development, mode of action, and there's just a ton of information that I think that we could share that may be of help to you. So first off, I want to talk about the impact of disease. Globally, it's estimated that between 20 and 40% of all crop yield is destroyed or lost due to pests and or disease. Here in the Midwest, it's not uncommon for 5 to 10% of our total corn and soybean bushels that we produce to be lost to disease, more than what we lose to either insects or weeds, which may be a surprise to some. So for centuries, we have been trying, or growers have been trying to minimize crop loss from disease. A lot of times using organic products or inorganic products like copper or sulfur or lime. And this goes back to the early times in ancient Egypt even. So it's literally been centuries that people have tried to fend off disease. I've even read articles about where they introduced smoke, where they would light fires and let smoke permeate through a canopy, thinking that that may help fend off diseases. But it really wasn't until a little bit more modern times, about 150 years ago, in 1860, there was a French chemist who figured out how to put together what is called a Bordeaux mixture, copper sulfate and calcium hydroxide, again, natural organic products. And they use it to control downy mildew in grapes. And what's maybe interesting, you could still use that product today. It's still used to some degree, not a large commercial scale, but it's interesting when you hear somebody talking about a Bordeaux mix, that's what they're talking about. So when it comes to the historical development, over the years we've had numerous advancements that's made through scientific discoveries by a host of researchers. And we've slowly shifted from these natural inorganic or organic compounds to newly developed organic fungicides, typically developed post-World War II. We've made a lot of additional refinements since the 1960s and have a better understanding of the mechanism of action of fungicides and are producing products that have a greater efficacy on disease. So in our product showcase here today, I thought it would be interesting to look at some of our history. And so we've actually applied 26 different fungicide treatments that represent technologies in use from the 1960s to today. Now, I can't talk about fungicides without talking about the big three. And by the big three, I'm talking about the big three modes of action that most of our growers employ, or what we in the plant pathologists use to control disease. The first being what we call DMI or SBI. They're dimethylation inhibitors or sterile biosynthesis inhibitors. If you pay attention to the FRAC code, that's the Fungicide Resistance Action Committee. It's FRAC code 3. Now the DMIs or the SBIs inhibit biosynthesis of ergosterol, which is a major component of the cell wall within fungal disease. So when we make applications of these FRAC code 3 fungicides to plants, what happens is the fungal organisms are attacked by the fungicide and it messes up the cell wall and the fungal organism dies or does not thrive. Now these fungicides are considered curative, which I'll talk a little bit more about later. One of the detriments is they don't have any residual. So basically short, or I shouldn't say any, but it's very short, limited to a few days, maybe a week at best. So these would be products that have to be maybe applied routinely or multiple times throughout a growing season. So there's old chemistry around. Propiconazole, for example, was developed in 1979. And then we've got some later ones that came after that, mycobutanol, tebuconazole, you maybe have heard of those. And then prothioconazole came out in 2002. BASF, interestingly, has the newest DMI on the market, methyltetraconazole, which we sell as Revysol. And that's a component of either voltema or Revitec, what we're going to talk a little bit about more later. Then we go into the FRAC code 11 or strobilurin fungicides. The quinone outside limiters, they inhibit fungal respiration by binding to the complex B3 complex within the mitochondria. big words. What does it mean? It basically tells you that they act within the cells of the fungal organism and shut down respiration, which is i.e. plant growth or fungal growth. Since fungal organisms are parasites, they can't rely on any other source of energy other than what they get from the plant. So by stopping respiration within the mitochondria, the fungal organism dies. They're broad spectrum. They're considered preventative. So we can apply them and they will prevent that infection from even occurring. They have excellent residual activity, around 30 days, some even a little more than that. Again, a lot of technology been on the market a while. Products like azoxystrobin came out in 1992. Then we saw the introduction of some other products in the 2000s, trifloxystrobin, pacoxystrobin, fluoxystrobin. The best of these products is actually Paraquastrobin, developed by BASF in the year 2000. Again, this is a component that we use in both Voltema and Revitec, our two key brands. But the interesting thing about strobilurins is they also have an effect on plant health. And if you think about it, what I told you earlier about affecting the mitochondria or respiration, plants also have mitochondria in their cells. So by applying a fungicide to that green plant, we can actually alter respiration slightly, and you get what we call a greening effect. And this is a big part of the plant health puzzle that makes strobilurin fungicides quite different from their counterparts. Lastly, of the big three, I want to talk about the SDHIs. Of the SDHI inhibitors, they've been around since the 60s, but the current chemistry we have on the market generally have all been developed in the last 20 years or 10 years. They're all considered to be third-generation products, beginning with Boscalid, which we use in Endura, which is an excellent white mold fungicide, for example. Fluxaperoxad, which would be the active ingredient that we add to Proxor, as well as a Revitec. So we have some great fits in all of these primary modes of action in the marketplace with our portfolio. Now, when it comes to disease management, or is it disease control, there's a lot of factors to consider, and I think there's a lot of, because of the terminology used by plant pathologists over the years, and some of the recommendations that we've heard over the past may not necessarily apply to us. You got to keep in mind a lot of the fungicides for row crops like corn and soybeans, for years we just allowed the diseases to proliferate because we had no solutions for them. We didn't have products available to us. A lot of these products were brought in from other markets, whether that be peanuts or some of the high-value crops, fruits, vegetables, etc. And again, it wasn't until we started to make applications to seed corn where people really saw an added benefit to somehow affecting plant health in addition to having disease control. So that's an interesting concept in itself. But when it comes to disease, prevention is critical. If you talk about diseases, we talk about symptoms and or signs. And symptoms would be where something is wrong with the plant. It may be stunting, it may be wilting, some type of discoloration. It's some obvious deformity or something is the matter with the plant. Then you can also see signs. Signs are the actual presence of the disease. This is the example of, the best example I can give you is go to your refrigerator at home, or remember that time you pulled out an orange with a bunch of green fuzz on it. That's actually the disease. That's not a symptom. You're looking at the actual disease. The problem is when we're trying to manage disease is when they attack the plant, they're invisible because spores are microscopic. So we may be looking at this beautiful soybean field behind me that may be infected, and we won't even know it for a while because it takes an inoculation period of about 10 days to 2 weeks for most diseases to take off. And so this is what I mean by preventative activity. If you applied a fungicide like Revitec today, the plant will be protected for up to 3 weeks or longer from an infection. So using my hand as a leaf, if a spore were to land on that leaf surface, it would not have the ability to attack that leaf. Now, what happens if it's already infection, or it has the infection? This is where those so-called curative products come into play. Because same scenario, you have the leaf surface, but now that spore has already penetrated the leaf surface and you have an infection underway. If you make the application of that triazole, that curative fungicide, within 24 to 48 hours of the infection, you can actually kill the disease. That's the trick. How do you know when your plant is 24 to 72 hours from the infection time? So again, that's where I like to say that preventative doesn't mean no disease, because it depends on when you apply. And curative does not mean curative in that regard either. It needs to be used preventatively, i.e. before you see any signs or symptoms of disease. The other thing to remember is that diseased plant tissue does not heal or go away. So if you have evidence of disease in your corn or soybean field, whether that be some type of spot or lesion or whatever, it's never going to go away. It's going to be with that plant until it dies. And ultimately what will happen is most fungal organisms are generally considered to be beneficial, because they come in late enough in the season, they'll actually start degrading the dry matter and what we call make humus, right? So it makes a lot of that residue go away over time, which is a beneficial byproduct of the fungal organisms. Again, the trick is to protect the plant long enough to get the crop that we want, and then go ahead and let the infection, there's a lot of saprophytic fungi, etc., that are responsible for degrading plant residue. Lastly, I want to leave you with some thoughts about plant health. And really, what does that mean? What am I talking about when I talk about plant health? And the reason I bring it up is because I think this is one of the big things that separates BASF chemistry from the competitive crop protection companies that are in the marketplace as well. When we developed Headline Fungicide, it was the first label to be registered with a plant health label, in addition to disease control. The body of research that went into that was over 7,000 research trials across diverse crops, over 1 million acres of trials. And we've proved that we can inhibit ethylene production, which is responsible for reducing stress and also allowing better water efficiency and utilization. It can actually help you during a dry period. We reduce oxidative stress. There's a lot of environmental things such as sunlight that can actually harm green plant tissue. Maximizing photosynthesis. This is another key component to plant health fungicides, and I talked a little bit about the greening effect, and we can see that visually. Improving nitrogen use and efficiency. We can grow more with less nitrogen when we treat it with some of our BASF fungicides. And these are all in addition to disease control. So that's one of the big things that separates us. The other thing I like to leave you with is also talking about technology development and the attitude or the goals that BASF has. We could bring a lot of products to the market. I've talked about products that are still in use today that have been here since the 70s. Some of our competitors are still marketing those products as their, quote unquote, best chemistry on the market, and they're utilizing some of these chemistries that were developed decades ago. That doesn't mean that's bad, but it means that there's probably better stuff out there, and you just have to look for it and find it. And that's what BASF has attempted to do. So instead of tweaking formulations, changing rates of old antiquated active ingredients, we're bringing new technology to the market. And so what this has led to is when we launched Headline Fungicide in 2004, it quickly became the #1 row crop fungicide. In 2010, we launched Headline AMP by bringing in new chemistry with Headline to produce the #1 product for use in corn. And in 2012, we developed Proxor fungicide, where we incorporated, again, new chemistry, state-of-the-art, to give us the best and the #1 soybean fungicide in the market. Now in 2020, or last year in 2020, we launched both voltema and Revitec. 2 new brands. You have your choice, either 2 mode of action or 3 mode of action, using the Group 7, the Group 3, and the Group 11 FRAC codes. So we have excellent resistant management built into these products, and they also represent the latest technology that we can bring to you So I know I've given you a lot of information today, hopefully something of value that you can utilize on your farm at home. But if you have questions, or ever have questions, I guess, there's a lot of information available at the BASF websites online, or certainly reach out to your local ag retailer or your local BASF sales representative, and they'll be glad to assist you. So thanks again.